What should modern programmers know? Let's get into it. Yes, tech support said they're coming out. Yeah, right. We'll see. So, okay. Well, what should programmers know? Okay, what modern programmers should know? And yeah, I haven't really watched this. It looked interesting. I wouldn't know what programmers are supposed to know because it'd be easy to like narrow it down. If we could just tell me the thing I need to know. Okay, here we go.
Yeah, so I would say if it were up to me, every programmer should know how to read basic assembly language instructions. Read,
Okay.
not write. And I want to be very clear on that. People like me.
No, definitely right. Reading is easy. Yeah, it's like what the hell is this thing doing? Yeah, if you go into my intro to programming or my programming how to program from the ground up course, it's on my GitHub. I show you how to read assembly. It's like super duper easy. It's like the most minimalistic, basic ass, tiny little changes. Basically, one step above electronics, just the electronics throwing switches or designing the bank of switches. It's just like one step above that with a bunch of like, there's little automated steps in the microcode that does all these things, for each assembly language instruction. Like reading it, yeah, it'd be good to like know what it's reading, but making sense of it, like what's actually going on, woo-hoo, or designing an assembly language program to actually do stuff. Let the compiler do that, but let's listen.
We don't really write assembly language hardly ever.
Right.
For testing, sometimes, or to figure out why there's a problem with something.
I think what he's talking about is like game dev. Game developers need to kind of know this stuff, but I don't think that's critical for application developers because we don't really look at the assembly language too often. Now, knowing how it works at the bottom level, crucial. And that seems to be a step that people have missed, or they think it's super complicated to understand. It's like, no, assembly language is dead dumb simple. It's like, okay, but what you're doing with it and why, now that's a whole other thing, right? That's a whole other thing. But what actually each instruction does is like the most micro, minute thing, but the cleverness involved from humans to make it do something useful and interface with the rest of the system. And yeah, that takes a little while if you're going to be doing that stuff. But what I think he's saying, and I think it's good to learn like what's going on underneath, to like have a concept of like, oh, this is just the microcode instructions that the CPU is running. It's not even abstracted. It's like that's the thing that's it's actually doing. And it's the instruction is abstracting the microcode sequence that the chip is doing, which is just flipping bits here and there and running around. And each bit has a meaning for this particular CPU. So you have to know all that junk, and it's like, ugh. But like going through it once for like one chip, yeah, like 6502 is probably the easiest one. Just understand what the hell all that stuff is. It's just little programs. That's all it is. Nothing. There's no magic. But it is clever how they set all this stuff up to run these pipelines. They do all kinds of statistical analysis on the damn thing. So it's useful to know. But like, I think what he's saying is like, know how things run underneath. At least have an insight about how you don't have to like be a master programmer of it, but like have an insight of what's going on. That's useful.
We might. And very occasionally, if there's really some super important thing, maybe someone will write some assembly language. But
never, application developers never do that. That's just not. I mean, let somebody else take care of it anyway. There's people that are totally like dedicated to doing that stuff who will never want to write an application in their lives, and you do have to rely on them. It is good to know at least once maybe how that stuff was put together. Go through that as a useful exercise. I wrote a printer driver when I did my assembly language course back in the 80s, actually, in San Diego at Claremont College. It was a really good course, a really good instructor. Probably one of the best instructors I've ever had was at this community college. And we learned assembly, and we built a print driver, which a spooler at the time was what they were called, where you'd usually have to wait for the printer. Like your machine would lock up while the printer is running. And what this thing let you do is spool it into RAM and then run off of that thing. And then you can go back to using your computer while it's printing at the same time. Ooh. It was a magic at the time. It was like, that's just kind of default behavior now. But at the time, it was like kind of a big deal to do all that stuff. And then doing it in assembly language lets you know how all this stuff was put together and all these different interrupts and things like you have to know about how this stuff works. That, once you know, you have a much better insight. It's really sad that like a lot of people think you can skip that step. It's like, no, it's kind of important.
By and large, when we talk about this kind of programming literacy, we're actually not talking about writing assembly. We're talking about reading it. Because most CPUs nowadays and most compilers can be coaxed into a position where they simply will do a fairly good job of executing code without you having to get in there and specify it. So there's a misconception that comes from a long time ago. It was true in the past, so it's not erroneous, but it is no longer really the case, that getting any kind of reasonable performance out of a computer meant hand coding things in assembly. Right. That is simply false. It isn't.
Right, because the chip is going to reorder it anyway, right? That's the thing. It's like, this is kind of a pointless activity because the chip will reorder it. It's like, oh shit.
Almost never done nowadays.
It's like your famous roller coaster tycoon, right?
Yes. That is almost never necessary. And to the extent that it is necessary, you're talking about very specific kernel, like not kernel the operating system, but like little nugget routines that
even these guys should not be messing with that stuff. Now, knowing how it fucking works, yes. And there's certain systems level or computer engineering stuff where they're trying to build stuff around these chips. That's a very, very, very small field. And if you would not be listening to this channel if you're interested in that kind of work. So it's like, I'm working on applications for people like to solve their problems. I'm leveraging the work that these guys do, which is totally necessary, needed, and useful. It's just I don't want to spend my time down there. It's like it's not that valuable. Now understanding how it works, yes.
That make a huge difference to something somewhere like video codec, right?
Yeah.
Where it's just
I'm not gonna write a video codec. No one that you know is gonna write a video codec. But the people that are into it, yeah, they got to pay attention to this stuff.
Going through and we want to be as fast as possible. Okay. But most code, no one is doing that, right?
True.
So when I say assembly language, I mean reading it. Being able to read basic ARM or basic x64 assembly language to the point that you understand the kinds of operations that the CPU does.
Yeah. So you can learn that in my course. I break it down. It's not complicated. It's actually very straightforward and simple. What is complicated is making that shit do something useful. That shit, okay, that's okay, yeah. You have to be super clever. You got to know all the details, how the stuff's worked out. Okay, I've already said
that. Then, understanding the CPU's execution model for those things and the basic speeds at which each of those things happen.
Relative speeds, I guess, one time through, seeing, certain things are faster, certain things are slower, depending on what you do. Sometimes how you put these things together, but again, the chip is going to do a lot of this stuff on its own, so okay.
Right?
I'm a big fan of this. I mean, in the web world, I talk about like...
But it's useful to know how it works.
You should have a really good heuristic for like how long it takes to go to the database versus to disk versus to RAM. This is like that at an even lower level.
Yeah,
right?
Yeah, okay. I mean, you have to test that stuff anyway, because a lot of stuff gets optimized away. You might do your calculations all perfect, but you missed the thing over here, or that thing is over there, or there's some kind of network in between. It's like, it's going to screw up all your numbers.
Right. Yes, it's the exact same thing. It's basically just saying every programmer should have, like a doctor, a lawyer. They have continuing ed credits they have to get. They have to go to like seminars and prove that they were still like.
Right. So they kind of forced it into something that was originally happening anyway. As these medical breakthroughs would happen, they would go out and visit to these doctors, and they would have to be in person and learn this stuff in person because there was no internet, and the book, you don't learn so much in the little books. It just kind of has to be verbal and hands-on, a lot of this stuff. So, and that's kind of how this field has been so far. It's like, if you don't want to keep up with that roller coaster and that treadmill, yeah, that's why people get burnt out. It's not because, the job's so hard. It's like learning something new and throwing away the thing you used to do. And, there's a new thing available. Or now that it's kind of slowed down a little bit lately, but there's periods of time when it gets really intense. And then I guess with the AI tooling stuff, you've had to like keep your ear to that a little bit. It's like how far, how fast, and is it really, all this hype wave shit that always comes through and says they're just kind of destroy the thing, and then return back later on. It's like, it's just another useful tool in the tool shed. It's not going to replace the 12 tool shed. It's just another tool, and so it's still can't get away with these pesky people in the loop. That's just the dream of all these programmers. Like, we just get the people out of the loop. It's like, people are still going to be looped. Like, compilers used to be done by hand. There would actually be someone called the compiler who would take your instructions and they would figure out what the bit code sequence is, and they would code that. Woof. Yes, they had to get a compiler to automate that shit quickly. But that was done by hand at one point. That was early on. So that was a thing. That job went away. We got automated away. It's like, yeah, but that was kind of a lame job anyway. That's really sucky job, like having to do that all day long. Ugh.
In my world, it'd be like programmers have to keep their knowledge up to date at roughly what is going on inside the computer. You don't have.
Yeah, on the computer. And for programmers also, I hate this word career, but like if you're going to be doing this stuff, you got to keep up with the changes and what's available and how people are doing stuff and what's the latest and what's coming up, what's going down. and you have to kind of pay attention to that stuff. Yeah, if you want to be in this for a while, and we're still at the start of this stuff, this computer stuff. We're still the starter. We've seen some revolutions, but we haven't really seen the full thing yet. It's still on the horizon. I know it seems like, oh, everything's been done. It's like, not really.
To be a master, you don't have to be Agner Fog and like be doing all kinds of crazy tests to figure out exactly how the iCache or the UOP cache is read, how many things it can feed from there to the back.
Yeah, screw that. It's all gonna be, no matter if you tried to push it into the thing, that the chips are gonna get to the point where it's like, we're gonna redo that on the fly. We're gonna look at what you're trying to do. It's like, we're gonna restructure that for our thing.
Back end in one site, like, okay, that's full-on hardcore optimization land. You don't have to go there, but just understanding basically this is what a CPU will do on one cycle. This is what it will kind of do.
Yeah.
Just getting that pipeline understanding. Here is how fast. And
6502, just learn that. You'll understand the basics. Everything else, they've just done stuff on top of that basics. I mean, how many things can it do? It's got to run through these instructions. It's got to read some stuff. It's got to write some stuff. It's got to look at inputs and branch. I mean, there's only so many things it can do.
L1, L2, L3, and main memory are. Here is how fast an SSD transfer is. Just that is, I think, something everyone should know. And that way, when they write a piece of code, they can go, wait a minute, this is doing like only, 2 milliseconds worth of operation, but it's taking like 5 seconds. Like, what happened, right?
Yeah, I mean, yeah.
And there's two benefits to this. One is now that programmer knows that they should be doing things differently. Find another library, find out.
Yeah, I mean, we used to be more aware of this now, but we've had this like hardcore like Moore's Law thing come along and like erase a lot of the things that we would not be able to do early on when this languages were developed and things like that. You had to pay attention more to these kinds of things. Now it's not as critical, but what we've kind of gotten lazy, and so a lot of these things, these bloat hardware, it's just like these things are running at like 1 billion times faster than the desktops, and they're still sluggish, still take time to boot up and everything. It's like, it should be like instantaneous by now, but it's not.
What's wrong with your VM? Find out what happened. Like, look into it, right? But the second thing is, the more you do that, the less you have to do it. Because if every JavaScript programmer got pissed off when something was going too slowly, then the backends and the API surfaces would all get better because no one will put up with it, right?
Right.
So
I mean, eventually, yeah, but the way we've been writing the software is not for that. It was for break fast, break things, move fast, and like we didn't make it out this quarter, and we just need to get to the next round of funding and just push it to production. We'll fix it in later, and can we H-1B visa the fuck out of this? Can we fire all the programmers and hire them overseas, or make the programmers train their overseas replacements, otherwise they won't get severance pay. It's all that shit. It's like, well, every little decision like that is going to add up to things being really kind of fucked up and doesn't work all the time. Something's wrong with it, and one's broken, a new version, but it's still got the same problems. Yeah, well, all that stuff's ripe for conquest. So yeah, I wanted to just give my reaction to what things programmers
pays dividends as well, right? Whereas if everyone's just happy with everything running super slowly, then the backends get slower, or they stagnate, or they don't they don't modify Python to fix the problems with it that make it hard to compile. They don't fix JavaScript's problems. They don't fix whatever, right? So the more people who are aware of this, the less structural decay there is as well, because people wouldn't put up with it.
Well, we put up with it because we put up with it because it's money. Right? Sales, money. So a lot of the things that were greenlit were because we could do it quickly and we want to get out the door, and it made money. So we just, oh shit, now what do we do? So, so a lot of the software, I'm under the opinion, most of it's just ripe for disruption, or because it's so poorly written and so hard, it's so expensive to maintain, that these companies without massive continuous injections of fresh capital will go out of business, and those things are open for disruption. So yeah, guys, give me a like and subscribe. Talk to you later.